The largest study yet of the most energetic particles to slam into Earth provides the first solid clues to where the particles come from. Using a giant array of tubs of water, scientists found that these ultra-high energy cosmic rays mostly originate outside the Milky Way. An international team analyzed about 12 years of data to show that particles with energies above 8 billion electron volts generally come from a particular direction in the sky, and it's not the galaxy's center. The researchers report their findings in the September 22 Science. It's the first clear experimental indication that the sources of these high-energy particles are located outside of our own galaxy, probably somewhere in the nearby universe, says Karl-Heinz Kompert of the University of Wuppertal in Germany, a spokesperson for the Pierre-Auger collaboration, which made the discovery. Cosmic rays are atomic nuclei that zip through space at the highest energies observed in nature. Some unknown engine accelerates them to energies 100 million times as high as that of protons in the Large Hadron Collider, the largest particle accelerator on Earth. SN, July 19, 2008, p. 16. Previous hints suggested that cosmic rays could be boosted to such high speeds by violent phenomena such as starbursts. SN, December 5, 2009, p. 8, supernovas. SN, March 23, 2013, p. 16, and supermassive black holes in the centers of galaxies, possibly including the black hole in the middle of the Milky Way. SN, November 10, 2007, p. 291. But the charged particles are difficult to track back to their homes because magnetic fields in space scatter the rays like fog scatters light. To overcome that uncertainty, researchers need lots of particles. It's a very hard problem to attack, maybe the hardest problem in high-energy astrophysics, says astroparticle physicist Vasiliki Pavlidou of the University of Crete in Heraklion, Greece, who was not involved in the new work. The Pierre-Auger Observatory in Argentina finds those particles using a collection of 1,600 tubs of ultra-pure water arranged over 3,000 square kilometers. That spread gives the observatory a better chance to detect the ultra-high energy cosmic rays, which are so rare that only one particle hits each square kilometer of Earth's atmosphere per year. Luckily, the tubs don't need to detect individual cosmic rays directly. Instead, the structures catch the cascade of particles cosmic rays produce when they slam into Earth's atmosphere, called an air shower. When the electrons, protons, muons and pions of the air shower run through the tubs of water, the particles give off a little burst of light called Cherenkov called radiation. The speed, direction and arrival time of the light can help identify where the original cosmic ray came from. The observatory caught 30,000 ultra-high energy cosmic rays between January 1, 2004, and August 31, 2016. The team found that, compared with the average density of particle strikes across the whole sky, about 6% fewer particles came from the center of the Milky Way. Slightly more particles came from a direction about 120 degrees away from the galactic center. Intriguingly, the excess points in the direction of the nearest cluster of galaxies to the Milky Way, located between 300 million and 900 million light-years from Earth. That finding suggests cosmic rays are produced in some galaxies, Kompert says, just not ours. Trying to identify which galaxies and seeing if there is any pattern linking them are the next steps. That research could help narrow down the processes that can accelerate cosmic rays. What we would like to understand is, not only what kind of sources they are, but also how these sources work. Kompert says. The new result is the most exciting thing that has happened in this field for a very long time, Pavlidou says. I definitely think the first experiment that will establish where these particles are coming from will get the Nobel Prize. But it's very hard. I think we have a decade still to go.